welcome to my channel. This is Jay from Coding with Jaybird, where I upload weekly tutorials to help build your confidence in coding. Today we're going to continue where we left off in our last video, where we talked about string and number data types. There are 5 remaining primitive data types that we're going to get into in today's lesson. Let's start coding, shall we? Now I'm continuing from where I left off last week, where we discussed the string and number data types. Now there are 5 other primitive data types in JavaScript, and we'll be focusing on those today: Boolean, Null, Undefined, BigInt, and Symbol. So what I've done is I've commented out last week's code so that we can focus on the current material in the console. There are 2 main categories of data types in JavaScript: primitives and objects. Objects are more complex, so we'll cover them later, but primitives are basically data types which are not objects and are very simple. Let's start with the Boolean data type. And this is our 3rd data type. Now Booleans are just a way of creating switches that can turn settings on or off. So they can be either true or false. To make things easy to read in the console, I'm going to put little title tags above each section. So let's call this one Boolean. Okay, so when Boolean, the way it works is you can make something either true or false. So let's create a variable, let is sleeping, is sleeping equals true. Now we don't wrap this in any quotations, we simply write true. Now if you're sleeping, that means you're not awake. So I could say let is awake equals false. Last class we looked at the type of operator, which we use to check the data type of a particular piece of data. So let's do that for type of is sleeping. And we can see the type is Boolean. So by writing true or writing false, it's understood that these variables are of type Boolean. Now Booleans are also used for conditional testing, such as creating a few variables and checking to see if they match or not. So let's say a equals 7, and then we'll let b equal 2, let c equal 7. And if we were to say, let's check console log a equals b, we'd get a false. So a is not equal to b, thus it returns false. We can also console log a equals c, and we'll see it's true. Our next data type that we'll cover will be the null data type. A null is totally empty and a meaningless value. A null either hasn't been set or is not applicable in a given context. So once again, I'm going to create my title of null. Now let's create a variable of null data type. We can easily do that by creating a variable. Let's say my empty var equals, and we set it to null. If I were to console log my empty var, we'd see the value null. So it's stored null. Now let's check the console for the data type using the type of operator on my empty var. We get something strange. We get object. Now that's kind of odd. We've stored the null value in this, meaning it should be of data type null. So this is a known error in JavaScript where nulls are returned as an object. The next data type that we'll cover is the undefined data type. Now, undefined data types are exactly what they sound like. They're simply undefined variables. Now, once again, let's create our heading. So I'll console log undefined. Okay, so how do we set a variable to undefined data type? Well, we simply declare it by saying let nothing. And then when we console log nothing, we'll see the value of nothing is undefined. And if we check the type of, so console log type of nothing, we also see undefined. We can also explicitly set the value of a variable to undefined. So let's go ahead and do that in a new variable called explicit nothing. So we're setting this explicit nothing to undefined. And if I log its type of to the console, explicit nothing, we'll see it's also of type undefined. All right, so we've covered the more basic primitive data types. Let's talk about one of the newer ones called symbol. Symbols are an ES6 data type, which are used as unique identifiers. They're created using the symbol function, which creates a new symbol. Now, symbols cannot be changed, meaning they are immutable and are unique. So once again, let's console log the title symbol so we can be clear about what we're looking at in the console. Now let's create a new symbol, and I'm going to call this my unique symbol, since symbols are always unique. And I'm going to use the symbol function, and in it I can choose to leave it empty, or in this case I'm going to pass in a string value which will end up being its description. And I'm passing in rubber duck. Now if I were to log this to the console, my unique symbol, I see symbol rubber duck. Now if I console log the type of my unique symbol, I see it's of type symbol. Now you can also pull out just a description of a symbol. So we'll log this to the console, my unique symbol dot description, and we'll see rubber duck here in the console. Now I mentioned that symbols are always unique, so let's check that. If I create a new symbol, so let's say new symbol equal, and I'll give it the same details. So symbol with the same description of rubber duck, and I console log a comparison of my unique symbol to new symbol, we get false. Now symbols are always unique regardless of their description. So that tells us though they both look exactly the same, they are stored as unique variables. We can also create a symbol and not store a description in it. So let my first symbol equal symbol, symbol. And I'm going to console log my first symbol dot description. And you can see it comes up as undefined, and that's because I haven't given the symbol a description value as of yet. I'm going to create another symbol, my second symbol, using the symbol function, and this time I'm going to give it a value of my unique symbol. Lastly, symbols don't auto-convert to a string. Now, most values in JavaScript will implicitly convert to a string. So for instance, if we were to have an alert message and I were to pass in something like my second symbol, this will produce an error. Uncaught type error cannot convert a symbol value to a string. So let's just copy that. This gives us an error. Type error cannot convert a symbol value to a string. So what if I wanted to alert the value of my second symbol? Well, we have to manually convert this to a string. So we can do that by using the toString method. So we can alert my second symbol dot toString. Oops. Now this is something we haven't covered yet. We'll eventually get to this method in future tutorials. For now, we're just converting the value of my second symbol to a string. And actually, we're still getting this error because I need to comment line 120 out. So I'll save that. And there we go. Symbol, my unique symbol. Great. Now our console's pretty full with all of this information. So for now, I'm just going to comment all of this out so that we can continue to our last data type. So let's comment all of this out. Start with a clear console. And we'll move on to our last data type, which is BigInt. So what is BigInt? Well, BigInt allows us to represent integer values that are very large. The number data type in JavaScript can precisely represent numbers up to the number dot max. Now you probably haven't seen this before, underscore safe integer, which equals, this is a long number, 900719254740991, which is the same as this. The problem is we lose precision when a number is greater than this value. So to avoid that, we use the data type BigInt. So I'll just log the title to the console once again. So one of the issues we have is when we're using really large numbers and we're not using the BigInt data type, we get unexpected rounding of these large numbers. So let's try the console log of, let's try something small like 9999. Okay, and we have how many nines here? 6 nines. If I save this, we see 6 nines. Everything looks good. This is accurate. However, if I were to console log something, let's say really large, now I'm not getting the 99 anymore. It's rounding up, as you can see, with the 100 and so on. So this tells us that we've lost precision. We'll check for precision in another large number now. So we'll console log, and I'll grab this number here, the max safe integer value, but I'll add 1 to it. So I'll change the last digit to a 2. And I'm going to check to see if this is equal to, and I'll paste the same number again, and now I'll change the last digit to 3. So this is 2 and this is 3. This should be giving us a false. However, if I save this, we get a true. So that tells me that we've lost precision when we get to numbers this high. Okay, let's practice creating a variable using the BigInt data type. So to do this, we append n to the end of an integer. To create a BigInt, we append n to the end of an integer. Okay, so let's say we have console log. I'll paste that same large number again. I'll change the last digit to a 5, and then I'll append an n to the end. And if I save this, I get an accurate description. It ends in 995. Now, if I were to log the same number without appending the n, so I'll delete the last digit, make it a 5, we see it rounded it up to 6. So it's not precise and it rounds up. Not precise and rounds up. We can also call the BigInt constructor if we want to create a BigInt. So this is called the BigInt constructor. And the way we do that is simply writing BigInt, and then we pass in the value. So once again, I'll paste that number and I'll change the last digit to a 5. Now we don't see this in the console because we're actually not outputting anything to the console. So what I'll do is I'll just wrap this whole constructor in brackets and I'll pass it into the console log function. And we can see we get a BigInt value that's pretty accurate. Now let's try something different. I'll console log 77n, and I'm going to check if it's got the exact equality. So the strict equality operator, which is triple equals, of just the number 77. And we get false. And that's because the 77n is of data type BigInt, and the 77 here is of type number. And we can check that by console logging the type of 77n, and we get that it's a BigInt. And if we console log the type of just 77, we see it's of type number. Lastly, it's important to note that BigInt is great when we're working with large numbers. Otherwise, we get unexpected rounding of these numbers, which makes our code unreliable and less secure, which we don't want. All right, everyone, that's it for today's tutorial. I hope you enjoyed watching this video. If you did, please don't forget to hit that like button and subscribe to my channel, where I'll upload weekly tutorials to help build your confidence in coding. Until next week, keep on coding.